Welcome to Thriving Academy. In today's class, we'll be looking at product rule. Remember, we stopped at product rule where I gave you guys an example. So in this class, we'll be looking at product also, looking at another example, which is find dy dx of 8x raised to the power 4 plus x raised to the power 5 and x squared plus x. Just as we did in our previous class, alright, we are still going to use the same formula of getting dy dx using the product rule. So if we compare this to our previous example, we simply say that from these two brackets, since this first bracket is multiplying the second bracket, we can simply say that this becomes our u and this becomes our v. If that is the case, we can simply say that from question, u is equal to 8x raised to the power of 4 plus x raised to the power of 5, and our v is equal to x raised to the power of 2 plus x. This is our u, this is our v. Recall the product rule formula. From product rule, we established that dy all over dx is equal to u dv over dx plus v du all over what? Dx. Since we have this, you can see that we have our u as this. So in place of u, you can simply put this. Then how do we get our v dv over ds? To get dv over ds, we have to differentiate our v here with respect to what? To x. Then here you have v, which is this, multiplying du over dx. To get du over dx, we have to differentiate our u here with respect to x. So let's do that differentiation. If we do that, u is equal to 8x raised to the power of 4 plus x raised to the power of 5. Let's get our du dx. And simply say that du all over dx here will now be equal to, differentiate x raised to the power of 4. We say that the power here will multiply the coefficient of x. So 4 times 8 here will give us 32. Then subtract 1 from the power. We're now going to have what? X raised to the power of 4. 1 minus 4 will give us 3. So differentiate 8x raised to the power of 4. You have 32x raised to the power of 3 plus differentiate x raised to the power of 5. If you differentiate x raised to the power of 5, we're going to, this 5 will come here to give us 5x. 5 minus 1 will give us 4. So if you differentiate u, which is equal to x4 plus x5, your du dx will give us 32x raised to the power of 3 plus 5x4. After differentiating u, bring out your v. We say that v is equal to x squared plus x. So dv dx also will be equal to, differentiate 2x. 2 will come here to give us 2x. 2 minus 1 will give us 1. X raised to the power 1 is the same thing as x. So there's no need to put the 1 plus. Differentiate x here. Differentiate x here. X here does it has, okay, has the power of 1. Assuming the power here is 1. For rule of differentiation, 1 multiply this one here to give us 1. 1 minus 1 will give us 0. Anything raised to the power of 0 is 1. So that 1 times this one will have this. So therefore, if we differentiate x, we are going to have 1. So if that is the case, we can simply say that if we differentiate this v equation, our dv dx will be equal to 2x plus 1. Since we have our du dx and our dv dx, and we also have our u and v, we can simply substitute inside the product rule formula, which says that dy dx is equal to u dv dx plus v du dx. If we substitute, our dy all over the x here will now be equal to, what is our u? Our u is 8x raised to the power of 4 plus x raised to the power of what? 5. Now our u is multiplying dv dx. What is dv dx? Dv dx is 2x plus 1. So in place of dv dx, you can simply put 2x plus 1. So if we do that, we're going to have this multiplied by 2x plus 1, where this first equation is our u, which is this. Then the second equation, this is our dv dx, which is this. Remember, these two are multiplying. That is why these two equations are multiplying. After that, we are done with this first part of the formula. We go to the second part, which says plus v. What is our v? We said that our v is equal to x squared plus x. So this becomes plus x squared plus x. Then our v is multiplying du over dx. And our du over dx is 32x cubed plus 5x4. So if the v is multiplying this, which is this, it means that our x squared plus x is also multiplying what we have here. So if we do our normal substitution, we are going to have x squared plus x multiplied by du dx, which is this, 32x raised to the power of 3 plus 5x raised to the power of 4. So this becomes this. This one here represents our du dx, while this represents our v. So after substituting the value of u, v, du, dx, and dv dx, we have to expand and open this bracket. I'm sure you know how to do expansion. If you don't know how to do expansion, go back to your textbook. All right, so use this bracket to open this. If we do that, we are going to have dy all over dx will be equal to x raised to power 4 times 2x will give us 16x raised to the power of 5. 8x raised to power 4 times 1 will give us plus 8x raised to the power of 5 raised to the power of 4. Then x raised to the power of 5 times 2x will give us plus 2x raised to the power of 2x raised to the power of 6. X raised to the power of 5 times 1 will give us plus x raised to the power of 5. This expansion is for our first bracket. Let's go to the second bracket. You have plus, which is this. X squared times 32x cubed will give us plus 32x raised to the power of 4. X squared times 5x raised to the power of 4 will give us plus 5x raised to the power of 6. X times 32x cubed will give us plus 32x4. X times 5x4 will give us plus 5x5. So we're going to have this. So from here now, we collect like terms. If we collect like terms, we are going to have dy. So collect like terms. When we did the multiplication, x squared times 32x raised to the power 3 is supposed to give us 32 raised to the power of 5. I put 4. That was a mistake. I just corrected that now. So if we collect like terms, we are going to have, let's start from the ones that have power of 6. If we start from those ones, we are going to have 2x raised to the power of 6 plus another power of 6 is the 5x raised to the power of 6. Think those are the only power of 6. Move to the ones that have power of 5, so it becomes plus 16x raised to the power of 5 plus x raised to the power of 5 plus 5x raised to the power of 5. I think those are the ones that have power of 5 plus 32x raised to the power of 5. So for 5, we have 1, 2, 3, and 4. 1, 2, 3, 4. Then we move to the ones that have power of 4, which is from here, plus 8x raised to the power of 4 plus 32x raised to the power of 4. If that is the case, we can see. So after collecting like terms, you add them together. If I add for 6 is this plus this. Add them together, you have 7x raised to power 6 plus add 16x plus 1, 17 plus 5 will give us 22. 22 plus 32 will give us 54x raised to the power of 5 plus 8 plus 32x4 will give us 40x raised to the power of 4. So this will give us, from this now, x raised to the power of 4 is common. Take it out. If we take it out, I will remove x raised to the power of 4 from here. We'll be left with 7x squared. Remove x raised to the power of 4 from here. We are going to have plus 54x. Remove x from here, we'll be left with 40. So if we differentiate that particular question, this becomes the final answer. Thank you. So in our next class, we'll be looking at one more example from product rule. Then we'll look at chain rule or quotient rule. Then if you haven't subscribed to our channel, don't forget to subscribe. Hit the subscribe button downward. Thank you.